For this practice problem, we want to find the critical points for this function. And we know that the critical values occur where h prime of x equals 0. So the first thing we're going to do is find h prime of x, and this is a simple power rule. So we're going to drop down that 4 and take 54 times 4, which is 216 x cubed plus then 27. And to find the critical points, we are going to set this 216x cubed plus 27 equal to 0, and we want to solve for x. To solve this function for x, we want to factor this. So I just want to make a quick little note about how to factor a sum of two cubes. So if you have a basic a cubed plus b cubed, this factors as a plus b times a squared minus ab plus b squared. And this is just a memorized factored form. So with our function, this 216x cubed, that's the same as 6x cubed. And 27 is the same as 3 cubed. So this will be plus 3 cubed equal to 0. And so we can factor this as 6x plus 3 times 6x squared minus 6x times 3 plus 3 squared. We're setting that equal to 0. So 6x plus 3 times 36x squared minus 18x plus 9 equal to 0. And then to solve this, we'll set each of these equal to 0. So the 6x plus 3 equal to 0, that's the easy one. Subtract 3, divide by 6, and we get x equal to negative 3 over 6, which is the same as negative 1/2. And then we also want to set this 36x squared minus 18x plus 9 equal to 0. We can divide everything by 9 and get 4x squared minus 2x plus 1 equal to 0. This isn't factorable, so let's throw it into the quadratic formula. So we'll have x equal to, remember, negative b plus or minus the square root of b squared minus 4ac all over 2a. So it will be negative 2 plus or minus the square root of negative 2 squared minus 4 times a times c all over 2 times a. And if you take a quick look, that value underneath the square root is going to be a negative because we're going to have 4 minus 16. So we'll have 2 plus or minus the square root of negative 12 over 8, and this is not real. So since this isn't a real value, it can't be a critical value. So our only critical value is this